In this session, we want to look at powers of complex numbers, in particular looking at de Moivre's theorem. Now, de Moivre was a French mathematician whose body of work included studies of probability theory and works on the normal distribution. And in about 1722, he came up with the power rule that says if we have a complex number z as the modulus of z times the cosine of theta plus I times the sine of theta, then we can find any power of z. Z to the nth power is going to be the modulus of z to the nth power multiplied by the cosine of n theta plus I times the sine of n theta. That tells us to take the power of any complex number. We write the number in polar form and then take the modulus to that power n and then multiply the argument by n as well. So if we have an example here, let z equal 2 times the cosine of 30 degrees plus I times the sine of 30 degrees. And if we wanted to find, say, z to the 10th power, well, we're going to take 2 to the 10th power and multiply that by the cosine of 10 times 30 degrees plus I times the sine of 10 times 30 degrees. And when we simplify, we would have z to the 10th. Now 2 to the 10 is 1024, and multiply that by the cosine of 300 degrees plus I times the sine of 300 degrees. Here's another example. Suppose the number was not in polar form to begin with, but if we have the square root of 3 minus I all raised to the 8th power. Well, we would like to first write this number in polar form, then we would apply our theorem, and then we rewrite in standard form. So those would be the three steps in computing this complex number to the 8th power. So let's begin by finding the modulus of z. The modulus of z is going to be the square root of the square root of 3 squared plus a negative 1 squared. And we can simplify. The modulus of z is equal to 3 plus 1, and continuing to simplify, the modulus of z is the square root of 4, and the square root of 4 is 2. Now we would like to find the argument, the angle that we are looking for here. To do that, here's the complex plane again, and the number square root of 3 minus I would be down in the 4th quadrant, and so we're looking for the angle in the 4th quadrant. Well, the tangent of theta is equal to the imaginary part divided by the real part. So that tells us the tangent of theta is equal to negative 1 divided by the square root of 3, or the tangent of theta is negative square root of 3 over 3. And we are looking for the angle whose tangent is negative square root of 3 over 3. If we remember, that would correspond to theta is negative pi over 6. And so going counterclockwise also correspond to theta is 11 pi over 6. So the next step is to apply our theorem, and we have our number z in polar form is going to equal 2 times the cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. Taking z to the 8th power says to take the modulus of z to the 8th power, so that would be 2 to the 8th power, and then multiply that by the cosine of 8 times 11 pi over 6 plus I times the sine of 8 times 11 pi over 6. And we can simplify. We'd have z to the 8th power. 2 to the 8 is 256. And 8 times 11 pi over 6. 2 goes into 6 3 times. 2 goes into 8 4 times, gives us 44 pi over 3. Cosine of 44 pi over 3 plus I times the sine of 44 pi over 3. So this angle 44 pi over 3 is coterminal to the angle 2 pi thirds. Z to the 8th is 256 times the cosine of 2 pi thirds plus I times the sine of 2 pi thirds. So in polar form, our complex number is 256 times the cosine of 2 pi thirds plus I times the sine of 2 pi thirds. Now, rewriting that back in standard form, we have to remember that the cosine of 2 pi thirds is negative 1/2, and the sine of 2 pi thirds is the square root of 3 over 2. So that number becomes 256 times quantity, negative 1/2 plus the square root of 3 over 2i. And when you use the distribution property, distribute the 256, and 256 times 1/2 is 128. So we have negative 128. And then 256 times the square root of 3 over 2i. The 2 can go into 256 128 times. So we'd have 128, the square root of 3i. And that would be the solution to the problem in standard form. Now, if we look at what it would take to multiply the square root of 3 minus I to the 8th power, what a daunting task it would be to take the square root of 3 minus I multiplied by the square root of 3 minus I multiplied by the square root of 3 minus I, so that we have 8 factors, and then distribute and multiply that out. It would take a good deal of work. And here, using this nice result, the power rule, it didn't take too long to give that answer of negative 128 plus 128 times the square root of 3i.